Right, so today we're going to be looking at visual representation of the atom, the Lewis dot diagram, and how that relates to bonding. So first, the Lewis dot diagram is going to represent the valence electrons, and those valence electrons are the ones in the outermost ring. Most atoms want to have 8 in their outer ring. We call that an octet. There are a few that want to have 2 if they only fill the first ring, which has 2 electrons, and we call that a duet. For the Lewis dot diagram, we always have the symbol in the middle, and then we draw the valence electrons around the outside. We have the valence electrons around the outside, and we only double them up whenever they need to be doubled up. And so we double up on oxygen or on chlorine, but only when we know that they have to. Our valence electrons, which we show in the Lewis dot diagrams, these electrons are responsible for bonding. They are also responsible for the reactivity of an element. So the more valence electrons that they have means that they're going to maybe either share electrons or steal electrons, but they'll be responsible for how the atom bonds and then how reactive it is as well. Whenever we look at the periodic table can tell us a few things about valence electrons or how many energy levels an atom has. And so looking at the periodic table, we have in the first group would have 1 valence electron, the second group has 2, the third group has 3, and so forth. We skip that middle section where the transition metals are. Those have a little bit less consistent valence electrons that you can predict, but the main groups, the tallest ones on the periodic table, we can predict those, which helps us then to predict the charge of the ion that will form. When we look at bonding, we are looking at chemical compounds, and so we have multiple atoms that are going to bond together, and they'll come together in a specific ratio. So whenever we have hydrogen and oxygen bond together, whenever they form water, we have 2 hydrogen atoms and 1 oxygen atom. We write this in a chemical formula, so we write H2O, where those little subscripts mean that that is the number of atoms. So the next one then is glucose, so that's C6H12O6, and so that means that we have 6 carbon, 12 hydrogen, and 6 oxygen atoms all combined together to make that glucose. For our chemical bonds, so whenever we form our chemical bonds, every atom wants to have 8 electrons in their outer shell for stability. And again, we call this an octet. And atoms can fulfill this need for a full outer shell by either sharing electrons in a covalent bond or transferring electrons in an ionic bond. Covalent bonds are the type of bond where electrons are being shared, and covalent bonds occur between 2 nonmetals. The nonmetals are found on the right-hand side of the periodic table, and they share in order to reach their octet, or in the case of hydrogen, maybe a duet. The resulting structure we call a molecule, and that is going to be any atoms bonded together by covalent bonds. There are 2 types of covalent bonds. We have a nonpolar covalent bond where the electrons are shared equally. So this is like whenever you share with a friend and you're able to say, well, I have 10 M&Ms and you can have 5 and I'll have 5, versus a polar covalent bond, which is where the electrons can be shared unevenly. And this is like when you're sharing with a younger sibling and you have 10 M&Ms and you say, I'll have 9, I'll give you 1. And most often this happens where a bigger atom will steal more of the electrons than the smaller atom, so the one that has more protons steals the electrons more. And what happens is then we have a partial charge on our atoms, and so this is really important whenever we start to look at water. So for example, this is hydrogen and oxygen. Oxygen is much bigger, and so even though it's sharing the electron with hydrogen, it's actually going to share it very unevenly, giving oxygen a negative charge and hydrogen a positive charge. The second type of bonds then that we look at are the ionic bonds, and they will be formed by donating or accepting electrons. So this occurs between a metal and a nonmetal. The metals are on the left-hand side, and that includes things like sodium, magnesium, calcium, potassium. And metals are going to lose an electron because they'll have a low number of valence electrons, and they'll become positive. And then the non-metal will gain the electron, which will make it negative. And so with these opposite charges, then they'll attract one another and form a strong association or a strong bond. So in summary, we have covalent bonds that are going to share together by sharing electrons to make their octet, even though the sharing might not always be fair, not always be equal. Ionic bonds will bond by transferring their electrons, and one will become positive, one will become negative, and then those opposite charges will attract.